So far, the improvement that we did when using the open source was to understand better how it works, to save on the speed, latency of calling the endpoint and saving on the cost, but also reducing the size of the vector. So now we have a 384 compared to 5 times the size if you're using the OpenAI. Sometimes bigger is better, sometimes smaller is better, but anyway, it's not much of an improvement overall. Now, let's check another example of a model that improves on the overall embedding accuracy for the retrieval part. So we will use two things here. One is the B encoder. That means that we can encode different parts of the dataset differently. In this sense, the documents and the queries. The second thing is that it will calculate a contextual embedding based on some sample documents. This is the best improvement over the naive embedding compared to a more complicated fine-tuning process that we can do. We're going to load our transformers from the hub. You can see that we have one transformer for the embedding and one for the tokenizer. They are not the same, but this tokenizer was used to train the data for the transformer, and therefore we can use it here. The model looks different than the model that we saw before. The main differences are the first stage that we have here and the second stage here, but the embedding looks quite the same. Again, the size of the embedding is a bit bigger. The vocabulary is slightly different. There is this part here that does the magic of changing the embedding based on the samples, again, to minimize the need for fine-tuning. But overall, it looks quite the same. We can still see what it does. We can still see the dropouts and the linears and the normalization and other things that the architects of this model tried to make those improvements. We're going to load a complicated data set. It's more complicated because it's in a different domain. This is financial opinion mining. The context is financial companies, stocks, and so on. And it has two types of documents. One is what we call the corpus, and the other one is the queries. The queries are the prompt that people did to find relevant documents. Because one is larger than the other, and the documents are usually larger, it makes sense to encode them differently. We have here the first 100 characters from each one of the documents, the sample of about 10 of them. And these are the queries. As you remember, they are different format because they are shorter, but still they might be more than 100 characters, so we cut them as well. But here, none of them was trimmed. So these are the contexts that we have. So the first stage in our improvement of the embedding is to select a sample. So we're going to have this prefix for each one of those types. And we're going to select a sample, the size of 512 documents out of the more than 50,000. And we'll use that to improve the embedding in the context of our documents. So we will put all those documents into our GPU or any other touch device. This is where the deep learning processes will run more efficiently. And we will go over the 512 documents in batch size of 32. And it will take us a couple of minutes. We have this kind of a 16 batches of 32 to go over all the documents and calculate the embedding of this batch. As we do that, we are modifying the embedding to fit the documents that we feed it. This way it takes a bit of a time. We will wait for it to end. When it's over, after about 2 minutes, we have a dataset embeddings. The 512 sample documents were calculated into a new embedding that now we can use it in our step 2 to embed the rest of the documents. Here we're not going to load all the documents, we're going to select a few of them. We're going to 16 documents and 16 queries. Each one of them will encode before we load it into the vector database using the second step of our model. So here we are calling the second stage. We are giving it the documents tokens that we calculated here. And we also passed the dataset embedding that we calculated in the previous stage, in stage 1. At the end of it, we have doc embedding. We can do the same to the queries. So each one of the queries will be encoded the same way. So we have the query tokens, and we pass the dataset embedding that we calculated in the first stage, and now we have a query embedding. So now we can compare what improvement did we get from this first stage where we adapt the embedding to the context of the documents. We will calculate the embedding of the same documents using the previous model, the general model without the context. We do the same for the queries. So now we have the query basic embedding and the doc basic embedding, and we will create a heat map that compares the doc embedding with the query embedding, and we have another heat map of the doc basic embedding and the query basic embedding. What we expect is to have some improvement in the fit. This is the basic model. You can see that most of the documents and queries have a very low similarity, and most of it is blue, except to this maybe area and a few others. While after the improved model, we can see that many of the queries and the documents have a much better similarities. Again, this area is still very yellow, so we didn't change much here, but we did have better results where many of the documents and queries are above 0.5, even 0.6. We shift the embedding to the area of the documents and the queries. Therefore, the retrieval part using the embedding similarities between queries and documents will be much higher.